Assalamualaikum dan selamat sejahtera. Today we are going to learn physics, EBelajau, physics form 4, chapter wave, subtopic 5.6 interference of wave. Okay, my name is Cikgu Suryati Yusof from Sekolah Menengah Sains Muzaffar Shah, Melaka, or known as Mosaic. Okay, interference of wave. So what we are going to learn today, first, explain the principle of superposition of wave. Second, describe the pattern of interference for water wave, sound wave, and light wave. Okay, diagram shows a water wave when two stones are thrown in the water. What happens if this water wave overlap? Okay, so look at the video.
But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference.
So this is what we call a pattern of interference. So we will learn more about interference. Okay, to begin with, let's do a very simple activity. The aim is to observe principle of superposition of wave. Okay, hold the slicky spring at both ends. So we have two students. One end hold the spring at one end. A pulse is given at each end simultaneously. Observe what happens when the two pulses moving opposite direction meet together. Okay, so when the two pulses meet, they overlap, then continue to move in their original direction. So we can see here from the video.
When two pulses meet, they overlap, then continue to move in their original directions.
So when two pulses meet, they will overlap and then continue to move in their original direction. Now we can compare the amplitude of the wave after they meet with the amplitude of the single wave before both wave pulses meet. Okay, so we have the two waves going to meet together and the amplitude, and then we compare the amplitude after they meet together. Okay, right, we can look at this video first. Okay, do you notice that? So this is a position where the amplitude is maximum. Okay, so amplitude of the wave after they meet is twice time higher. So write an equation to relate both amplitudes of two pulses before they meet with the resultant amplitude after they meet together. So before both students give a pulse of amplitude A, so this is A, and they get the result. When they meet together, the amplitude is bigger, equals to 2A. A plus A equals to 2A. Maybe you can see again. We can watch again here. So this is the point where we have a bigger amplitude. Okay. 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 Now, by combining the two overlapping waves can be explained by principle of superposition. So we have A1, this pulse move from left to right. Okay, with the amplitude A1, and then a wave move from right to left with a smaller amplitude A2. They will meet together at this point. Okay, so when the two pulses overlap, the resultant displacement is the sum of the individual displacement of the two waves. Means that A1 plus A2 will become A3. Okay, will become A3. So bigger amplitude. Now, so this is what we call interference of wave. So what is interference of wave? So interference is the superposition of two waves originating from two coherent sources. Okay, so after this we'll discuss what is the meaning of coherent sources. So we have the word superposition means, so this is the first wave, the first throw, and this one is the crest and the crest. So they were in phase. So we have a larger throw and a larger crest. So this is what we call constructive interference. So another one, we have a throw meets a crest. Crest meet throw. So this is what we call out of phase. Right. So this is what we call disruptive interference when the amplitude is equals to 0. Okay. So we start with this video first. Okay, two poles meet together. They will superpose with a larger amplitude. After that, they will move together in their original position. Okay. Okay, so they superpose. The relative force has higher amplitude. Okay. So this is what we call constructive interference. Okay. Now we have two negative poles meet. They also will superpose. The resultant negative also has a bigger negative amplitude. So look at the video. Okay, negative amplitude. So it will have a bigger negative amplitude. Okay, the poles combined of the same amplitude but are out of phase. The resultant amplitude is 0. Okay, so positive amplitude, negative amplitude. So superpose and we get 0 amplitude. Okay, this is known as disruptive interference. Okay, disruptive interference. Okay, so now we conclude what we learned just now. Okay, so two crests meet together. We have a bigger amplitude of crest. So resultant crest has higher amplitude. This one we have negative crest. This we call throw, negative amplitude. So meet together we have a bigger negative amplitude or negative throw. So this is what we call constructive interference. Okay. Now we have another one, a throw, a crest and a throw meet together. So we have a resultant amplitude is 0. So this is what we call disruptive interference. Okay. Now is the meaning of two coherent sources. So the wave from coherent sources have the same frequency, same wavelength and constant phase difference. Okay. For example, we have a water wave. So we have two dippers with connecting with the same motor. So both have the same frequency and move with the same phase difference, move with the same direction. Next, we have a double slit for the light wave. So this is a double slit. So the light will come to the two slit and the wave will be coincide to form interference pattern. So we have a bright and dark fringes alternately. So this is for double slit. So the double slit is the two coherent sources. And lastly, we have a sound wave. We have the coherent sources is the two loudspeaker, which the loudspeaker are connected with a signal generator, with the same signal generator which produce the same frequency. Okay. Now again, we look at what is the meaning of constructive interference. Occurs when two crests or throw are coincide to produce a wave with crest and throw of maximum amplitude. So two crests coincide means they meet together to produce a bigger crest, and another one is we have a throw and a throw to produce a bigger throw. Okay, we can look at this video. Okay, two crests made together, we have a bigger amplitude of crest. Okay, again. Okay, we can also have two throw meet together at one point. Okay, so it will produce a bigger throw. Okay, bigger maximum of throw. Okay, this is what we call constructive interference. Okay, next we look at disruptive interference. Okay, what is the meaning of disruptive interference? Occurs when crest of one wave coincide with the throw of the other wave, thus cancelling each other, with the result that the resultant amplitude is 0. Means that crest and throw, this is out of phase and coincide. The one throw, crest and throw, which is what we call out of phase. So we will produce zero amplitude. Okay, zero amplitude. So you can look here from the video. So it will be zero amplitude. Okay. So this is destructive interference. Okay, so as a let's look at conclusion. Okay, constructive interference and destructive interference. Okay, now for water wave, the object will move up and down. So when you have an object at the location of the constructive interference, it will move up and down. And when it is at the destructive interference, the water becomes calm. So the object will not moving or stationary. For light wave, what you see is light, we have bright region, and for destructive interference is dark region. For sound wave, sound, constructive interference is a loud sound, destructive interference consider the soft sound or silence. Okay. Now let's move with the first wave, activity 2, to study interference pattern of water wave. So we set up a ripple tank. So this time we use two dippers, two spherical dippers to produce two circular wave. Okay, then both circular wave will coincide to interfere, and we look at the image of the interference pattern on the piece of paper here. Okay. Now, the first question, compare the frequency of the two sets of continuous circular wave. So you should have the same frequency because the dippers vibrate with the same motor. Okay, with the same frequency. What is the name given to the source which has the same frequency and same phase difference? So this is known as two coherent sources. Okay. So this video. So this is a pattern of interference pattern from two dippers in the water wave. It's very nice patterns, right? Okay, so we have a pattern like this. So this is the what we call interference, constructive interference, and the line here is what we call destructive interference. Okay, we can see at this animations, very nice animation here. So this is what we call the patterns of the interference of water wave. Okay. Okay, so this is where the location of the constructive interference, and the line here is what we call destructive interference. Okay, right. Okay, the interference pattern of water wave, which is observed through a stroboscope, mark and label on the diagram the region constructive interference. So this will be constructive interference. Destructive interference will be the line here. Okay, so we have alternately destructive and constructive interference. Okay. What happens to the water at region constructive interference? So, okay, again, this is constructive interference. This is the destructive interference. So at the water constructive interference is at the object at that location, it will move up and down with high amplitude. Next, what happens to the water at region destructive interference? So the water will become calm, and the object on this region will stay stationary. Now let's look at terms regarding interference. The first one is antinode. Antinode is a point where constructive interference occurs. Node is a point where destructive interference occurs. Antinode line is a line which connects all antinode points. Node line, a line which connects all node points. Okay, so looks at this example. So this is the antinodes. Okay, so the line that connect is so the point where constructive interference occurs. So the line that connect all the points is what we call antinode lines, which is the line connect all antinodes point. Okay. Nodes we have is the point where the destructive interference occur. So this is the blue dot is where the location of destructive interference. Remember, this is the crest, and the light line is the throw. So crest and throw. So the line that joining the points is what we call nodal line. That is line connect all nodes point. Okay. Now we have this diagram. Okay. Remember the thick line is represent the crest, and the dotted line is represent the throw of the wave. Now we have 3 points given here, point A, point B, point C. S1, S2 are the two dippers. Okay. Okay, so what happened at point A? The two crests meet, and when the two crests meet at point A, so A is we have throw and throw, right? So we have throw and throw, so it will be constructive interference. At point B, two throw meet. Okay, this is point B, two throw meets. Okay, so we get constructive interference. At point C, a crest meet a throw. So this is point C, so this is definitely what we call that disruptive interference. So let's label the point of antinodes and nodes line. Okay, this is the first one. Throw and throw. Crest and crest, throw and throw, crest and crest, throw and throw. So this is the line what we call nodal antinode line. Again, so this is antinodes. This is antinode line. Again, this is antinodes point, and this is antinode line. Now we move on to the second one is the yellow point represent the nodes point. So this is the nodal line. Okay. Again, nodes. So we get nodal line. Okay, node line, node point. Sorry, node point. So this is nodal line. Okay, so we try to label it. Antinode line is the node line is the red one. Antinode line is the this supposed to be node line. Antinode line is this one, the blue one. So this antinode line. Okay. Alright. So next, looks at more detail. So we have terms. We have to know what is the meaning of the certain measurement. We can make certain measurement here. Okay. The first one, we have lambda. So lambda is given as again we draw the line. Okay. So this is the line. Remember, the blue is the antinode line. The red one is the nodal line. Okay, so this is the point S1, S2 here. And here we draw a line here, which is perpendicular with this line. So this line is what we call D. The line is from here, from the deepest to the where we make a line here. Okay. So the first one is this is what you call A. So the distance between two dippers S1 and S2 is called A. That is the distance between two coherent sources. Okay. This is lambda. So lambda is from one crest to another crest. So this is lambda. And here we have another from line antinode line to another antinode line, successive antinode line. So this is what we call X. So again another X. So also X is from one nodal line to another nodal line. Two successive nodal lines. The distance between two successive nodal lines. Okay. So lambda is the wavelength. A represents distance between two coherent sources. D distance between two coherent sources, and where X is measured. Okay, X is the distance between two successive antinode line or nodal line. The word successive is important because from one line to another line. Okay, and we have the formula lambda equals to AX over D. Okay. Normally, the purpose of this formula is to determine the value of lambda for wavelength. Okay. Right, this is the experiment that I did in my class. Okay, so this is the image formed on the mahjong paper. So we label it. So this is one dipper, another dipper. So this is A. So this is the distance. Okay, I draw a line here. So this is from the 2 point to where I line here is called D. And this is X. X is the distance between one nodal line to another nodal line. Okay. So we can measure the value, determine the value of lambda by using the formula lambda equals to ax over d. Okay. Okay, let's try one question here. So now here is A, here is location. Okay, so this is one, this is a crest. So this is puncak crest. So one antinode line, another antinode line. So this distance is what we call x. So what we can do is we measure this. This is 3.8. So A refer to 3.8 centimeter. X equals to, this is x, 2.2 cm, and D is measure 8 cm. So use the formula lambda equals to x over d, and we get lambda equals to 1.05 centimeter. And you can test is it right or not by measuring the real value of lambda on this picture. Okay, so now looks at here before. So we have two A's move together. This is crest to crest. During, we have bigger 2A, and after they will move in their original position. Okay, so this one will continue move to the left, and this one continue move to the right. Okay, now you have A and 2A. So crest and another one crest of 2A, so it will become 3A. Okay. Remember, superposition A plus 2A equals to TA. And after that, they move, continue to move in the original position. And this one you have A, positive A and minus A crest. So this is referred to crest, this is referred to throw. So we have 0 amplitude. After that, they will move back to original position. Okay, so that's okay. Thank you. So I hope you understand. So see you again for the next topic. We still have the topic to study the factors which affect the interference pattern of wave. Alright. Okay. Bye.